Welcome to Perpetual Learning. My name is Rajat Kumar Shukla. Today we will discuss about space vector pulse width modulation. In last lecture, I have mentioned about what is the basics of space vector pulse width modulation and how hexagonal MAD and what is the basic concepts behind the space vector pulse width modulation, what is the difference between the sinusoidal pulse width modulation and space vector pulse width modulation. In today's lecture, I will show you the implementation of the space vector modulation in the MATLAB, and as well as I will show you some information about space vector pulse width modulation. Implementation time, this problem is very difficult to understand. So last video we have successfully calculated the active vector time, which is called here t1 and t2, right? And for each sector this value will be changed. Okay, here in this paper the table for the each sector, the time calculation is here. T0 is a 0 vector time for the vector 0 and for the vector v7, where is the switching sequence for a b c is 0 0 0 and 1 1 1. If you don't know about 1 0 what is happening here, then you should go my previous lectures and you should try to what is the meaning of 1 1 1 and 0 0 0 to understand this. Okay, so let me clarify this here. Let me clarify this in further information what is happening there, right? So here the actually in space vector pulse width modulation, one important point which is called the switching sequence selection. The first rule to choose the switching sequence, why in this interval 0 0 0 and why this interval 1 0 0 switching sequence is here. This is called a v1 vector, this is called a v2 vector, this is called a v7 vector, this is called a v0 vector for the sector 1 operation. Okay, right? So and again this is happening here, right? v7 is here and v2, then v2 is here and v1 is here and v7 is here. Okay, so how to choose this switching sequence only? And another question come into the mind, that is the why we say the losses included in the space vector modulation technique is less as compared to sinusoidal pulse width modulation technique. Why? So this is the answer of this question is here. Okay, so let's see the rule number 1, how to choose the switching sequence after this here and why after this is here. Why not v2 vector is here and v1 vector is here? So to avoid the losses, the first rule is the active state 1 and 2 and 3 till the v6. This is the active states. The active states must be applied at least once in a subcycle. Okay, let's say this is a one subcycle, right? This is a one subcycle, this is a second subcycle. Okay, so in the first subcycle the active state v1 and v2 in subcycle, right? In subcycle, that means in here to in this area to this area, right? This line to this line, right? So here the active state v1 v2 at least applied at once. Okay, so in a subcycle, right? So here applied, doesn't matter how much 0 vector is here. Okay, doesn't matter, but the point is v1 and v2 should be here. And the second point, which is one of the very important point regarding only one phase must switch for a state transition, right? Only one phase. That means here if I say that I call this name is let's say A, this B, this C. Okay, so in A here 0 0 0. Okay, don't call I'm not calling this A, this capital B and this capital C, it's better. So in capital A small a, small b, small c, I have already said the phase value, okay, the phases value. So in here a, b, c, so in the b interval, this called 1 0 0, that means phase A is transit only at once. Okay, so what is my point? The second point, only one phase must switch, so only one phase must switch, okay, for a state transition. If whenever you jump from this switching this vector to this vector, then the switching sequence should be as the phase transition, only one phase should be transit. This is a very important point. Okay, now the third point, which is related to the zero vector, that is either the zero state, v0 or v7 must be applied at least once. Okay, must be applied at least once. That means no need of v7 applied again and again. Okay, so this is your responsibility how to choose that. So I am showing you 1 to 2 switching sequences. For example, you can say that this would be here or not. Just find out, just check out this. Okay, so if I choose first vector is v0, second vector is v1, if third vector is v2 and fourth vector is v1, is it possible? Zero vector, that means 0 0 0, v1 vector, that means 1 0 0, v2 vector is 1 1 0, and v1 vector, that means again 1 0 0. So the phase switching in each interval, I mean in consecutive interval, the switching sequence should be, the phase transition should be, only one phase should be transit. Okay, so here a phase b, see, right, so here 0 to 1 only transit, another remains same. Okay, so that means the phase transition, only a phase will be shifting from positive to the negative, that means it is valid. Now just check here, for 1 0 0, here 1 is already here, 0 is already here 1 is already here in A, in C, only B phase is transit, right, only one B phase is transit. Then this sequence is okay, is good. And again for 1 0 0, last one is then 1 and 0, 1 and 0 for A and C is remain same, only B phase is transit right here again. So that means we can say, doesn't matter, one phase transit again and again, but the point is in consecutive switching sequences there should be one phase should transit, right? So this is a point. Okay, so this vector is valid. If I say if I say that v0, v1, v0 and v1 again, so v0 that means 0 0 0, v1 that means 1 0 0, one phase is transit. Okay, that's good. v0 0 0 0 0, then again one phase, one sequence is transit. Okay, then again is good. And 1 0 0, then one sequence is, sorry, here is again 1 0 more, then 0 sequences here to here is transit, right? So what it's mean here, according to one phase transition this rule valid, but according to first rule, what all active vectors should be here in one subcycle, right? So in one subcycle, if I say this vector, then v2 vector is also is here, v2 vector is not here, so that means this is not valid sequence. So according to that you can make your own switching sequence. Not necessary just follow this conventional rule, but you can choose your desirable switching sequence, right, where you find that this switching sequence will provide you less switching losses. And obviously this is one of the good point for the research and for the project making purpose. The research papers will provide you the better information about that. So the voltage, what is the switching pulse response for each subcycle is shown. Okay, so here one more point, let me explain this. If I say the voltage vector is I mean this is a hexagonal, here, and if I am assuming the reference vector the reference vector is lying in this first cycle, right? This term. Okay, so let's say this is the reference value. Okay, VR star is here. Sampling time, the sampling time is here. This sampling time TS is approximately equal to 10 microsecond, which is very higher for 20 millisecond. Or we can say that yeah, obviously that 50 hertz. Okay, so because 50 hertz is required, and this 10 microsecond time is very much higher for I mean this is this 10 microsecond is very less for from 50 hertz time signal. Okay, 50 hertz time signal, that means 20 millisecond. So obviously if reference vector, this reference vector will be moving accordingly 20 millisecond, or you can say 50 hertz response. So and if apply the carrier signal, one of the carrier signal for the some instances like you can say for the sampling time TS value, then you will get what is the position of the reference vector value, right? So should generate the whatever required value, what is the VA star, VB star and VC star, and you convert it into the magnitude and angle value. This magnitude value, this is nothing but it's VR star, and this angle value is nothing but what is the position of the reference vector lying in different sectors. Okay, if I say this is the time signal, and this is a time, and VA star line, because this VA star is looking like DC signal. Okay, and this VB star is here, right? So this VB star is here and this VC star is here. Okay, actually the carrier voltage wave is very carrier voltage frequency is very high, or you can say the sampling time. If I say this is for the sampling time is here, then obviously to generate the switching signals here, if you generate the switching signals here, let's say this VA star for the phase A value, then you can say this value is, and this for this value is here, the switching signal S1 should be like this. Let's say you applying some condition that whenever the carrier signal will be more than this, then output the switching signal for switching pulses is 0, otherwise 1. Okay, similarly is here, and similarly for phase A, that means S3 pulse is here, then what you will apply, obviously this VB star is here, then for this value and for this value the pulses for in this duration is 1, and similarly for phase C, right? You can say here similarly situation, similarly incident is here. Okay, so for S1 is applying is here, S3 is applying is here, S5 is applying is here, and obviously this S2 is complementary system, then S1 is complementary of S2, so the pulses will be just reverse here. S4 is for the S3 and S5 is for S6 is for the S5, so pulses is just reverses, so nothing to worry for this. These three switching signals, just worry about S1, S3 and S5 switching signals. And for what much time will be spent is here, as for the T1 time spent is here, for T2 time is spent is here, and similarly for 0 vector T0 by 2 and T0 by 2 is both side in one subcycle, because this is a one subcycle is happening, and for TS is here, right? And for the each sector, because this is happening in sector 1 and this sector 2, this is for sector 2 and this is for sector 3, this figure number 8, and this is for figure number this is for sector 4, this is in figure number 9, and so on and so on. Now here, which voltage vector will be operate for each sector showing here, and the upper switching, this is very important in implementation purpose. S1, S3, S5, the timing schedule is already is showing here. Okay, we have to generate the reference voltage vector value. Okay, so let's see, this is possible by the 3-phase voltage vector. Otherwise, let's check the value of the sinusoidal pulse of the single phase generation in the MATLAB, right? So here, this is for the VA star generation, which is nothing but in sinusoidal fashion. This is 120 degree apart, and this is 240 degree apart, right? VC star, and these three all is sinusoidal pulse width generation. Here, after getting this voltage signal, you have to convert 3-phase to 2-phase conversion, which is nothing but called Clark operation. Okay, then you will get alpha axis and you will get beta axis. Now the alpha and beta need to be converted magnitude and angle value. Okay, how we will convert it, I will show you in MATLAB session. This magnitude and this angle you have to apply it in hexagonal MATLAB programming. You can make this hexagonal programming in the user defined function, or you can use your simulation blocks diagram. But here in my case, I will show you how we will make. But the behind of that concept, let me discuss again, and let me summarize again what is the basic concept of the SVM. Okay, so you have to generate one more pulse signal, which is nothing but the triangular wave signal, which is like a VC vector, and you should aware what is the sampling time, what is the TC, and what is the modulation index where you are operating, and so on, right? And these three signal applied in one MATLAB programming, where you will identify where the reference voltage value, which is where it is lying here or here or here, so on. After that condition, you will get the switching pulses, right? Directly switching pulses, and these switching pulses you can apply in 2-level converter, which is 2-level VSI, which is nothing but 3-phase normal circuit, and after that you can apply the load. Okay, this load may be induction motor, RL circuit, and so on, whatever you require, whatever your load in 3-phase condition. Okay, so this is a basic block diagram, how we operate, how we implement the space vector pulse width modulation. Okay, let's see in the MATLAB tool how it's look like here. Okay, so first this is the SVM control panel, and here this is a simple 2-level 3-phase circuit. Okay, so this is a term, I mean this term transformer, this is just a transformation of the 3-phase to 2-phase conversion, and here this is a reference 3-phase generator. What is the value? VM 2πf. Here of course there is a one M file where f is where I have set f value is 50 Hz, and I have set a VM value is 220 multiply square root of 2, right? And similarly VB, I have shifted the phase value here 2π/3. Okay, similarly VC is here. Okay, so this is according to me. You can change your phase value and you can use your phase value, right? So here this D and Q, that is nothing but if you want to say the alpha and beta, and this you can say this is just a normal Clark transformation, and here I have just converted into the magnitude and angle value, and this is the output of the angle, this is the output of the magnitude. Okay, so here all signals, here 0 is no need to use in your case, and this is a carrier signal I have generated. Here one more question, yeah, obviously, that what is a VC is here. This VC actually I have generated from my M file. One M file is there, and now one point, this is a hexagonal programming is here. So what is inside the hexagonal programming? Like in hexagonal programming, see here in hexagonal programming there is a function where already I have I have made a program of the in the function command. Here U is the coming signal, where if I say this signal is U of 1, this signal is U of 2, this signal is U of 3, and this signal is U of 4, then the merging signal called U, right? And here TS I have used the 200 microsecond, which is obviously little bit lower as compared to 50 has 20 millisecond operation, right? And the VDC value I have used the 220, and so on. The modulation index is A, and this value, this if command, is showing how to identify the sectors. Okay, here 0 1 1, here v1 vector is nothing but already said this is the 0 1 1 1. What is the value for the S1, right? So in the programming I have used same. Okay, similarly for v2, similarly for v3. Okay, so after checking this command for signal, I will get what is the exact location, if it is in exact location of the sector 1, by choosing the by checking the angle. Okay, then this will lie here, otherwise it will jump directly to the here. How to sense? Just I have said that angle, what is the angle of the reference voltage value, right? And according to that the time equation will be changed, and similarly same programming is here. Okay, here if you unable to understand how to program, here I have done, then you can put a message in our inbox and you can ask something about your projects. Okay, now this pulses I have just go to, and I have used the go to block and from block to passing the signal here. So similarly for the switch 2 is here, similarly for switch 3 is here, and switch 4 and switch 5 and switch 6. Sorry for that, this connection is not connecting is here. Now I have connected. I am running this signal, I am running this simulation, then I will get what is the signal is here. Oh, that's looking very nice. And here I am just zoom out this value, then you will get looking like this. Okay, here this value is just a phase value, and this value is a line value which is showing here. And if I just use that signal, this is look like this, which is very good to see. Let's check what is the frequency of the phase value. Then to check out this, I am just opening the measurement of the scope, and just see here Okay, so this 2 points is completing the one cycle. Then let's see the time. Differentiation of the time is nothing but 20.039 millisecond, which is very good, and the inverse of this, which is 49.903 hertz, that is nothing but it's approximately equal to the 50 hertz, which is quite good response to the inverter, good response to the load. This is the load part. Actually, you can change your according to your what is the requirement of the load. If you are working in the dry case, then obviously this load should be changed by the induction motor. You can just write a message. You can mail me by this email ID, and you can use our WhatsApp, Telegram groups, or obviously YouTube is here, and you can put a message in our comment box. Then what is your doubt? If you are working in the MTech project, if you are working in the BTech project, then this concept is very well for you to improve your knowledge and to improve yourself. Okay, thank you.